Hi friends, welcome to a new session. So today's session we are going to analyze expectation value of potential energy, which is again a topic in quantum mechanics. So let us go straight to the question. The question is show that the energy E is equal to expectation value potential energy in the stationary state of hydrogen atom. So we know that the question should be, there is a small correction in this question. Actually, En should be equal to 1 by 2 times expectation value of potential energy. This should be the question. So let us see how this can be done. So before that, let us take the oneness state of a hydrogen atom. So we can represent this by psi NLM. These are quantum numbers. So we have psi 1 0 0 because for oneness n is equal to 1, L is equal to 0, so M is equal to 0. This state we can write as 1 by root of pi a0 cube into e raised to minus r by a0. This is the wave function. So we know that the corresponding a0 is a Bohr radius. A0 is given by is equal to h cross square by me square. So we here also know that the energy of the hydrogen atom is equal to minus e square by 2a0 n square. So we have to prove that this is equation number 1. So we have to prove that this is equal to half times expectation value of potential energy. So we know that how we will calculate expectation value. Expectation value of any function, say it is x, any variable is equal to integral psi star x psi dx. So same thing we will apply here. We have to calculate here the expectation value of potential energy, which is equal to integral psi star v psi d tau. We are taking the three-dimensional integral, volume integral. So this is a d tau. So now we will substitute. We have to just substitute the values. So integral. Here there are three integrals. Since it is a volume integral and we put it in spherical polar coordinates, so we have three integrals will coming. I will explain that. So instead of psi star, we have 1 by root pi 0 cube e raised to minus r by 0, and here the potential energy is given by minus e square by r into again psi 1 by root of pi a0 cube e raised to minus r by a0. Now let's put the integrals. Integral here it is given as d tau. Now the d tau is equal to r square sin theta dr d theta d phi. Here r goes from 0 to infinity, theta goes from 0 to pi, and phi goes from 0 to 2 pi. So we have to substitute these things. So let's calculate the angular part separately. So here in this wave function there is no angular part. So we can calculate integral of angular parts, which is given equal to integral of only angular parts are given by 4 pi. So let's keep that and let's evaluate the rest of the integral. So this expectation value of potential energy integral are equal to 0 to infinity. And the other parts we have calculated 1 by pi a0 cube into e minus e square into 1 by r e raised to minus 2r by a0 into integral of the angular part is 4 pi into dr. Sorry, r square dr. This is what we will get. So let's simplify this. We can take the constants outside. So we will get minus e square by pi a0 cube into 4 pi integral 0 to infinity. This r and this r square will get cancelled. So we remain with e raised to minus 2r by a0 dr. Now this is very simple. So we will get here it is minus 4e square by a0 cube integral 0 to infinity r e raised to minus 2r by a0 dr. So this is just like integral of a product. Now we know that integral of a product we can calculate as integral ab dx equal to first function into integral of the second minus integral of derivative of the first into integral of the second dx. So applying this here, we will get here minus 4e square by a0 cube. Let's take r as the first function. So r into e raised to minus 2r by a0 by minus 2 by a0 from 0 to infinity minus integral of derivative of first is 1 raised to minus 2r by a0 minus 2 by a0 dr. So this is equal to this term when it is infinity, r is infinity, this e raised to minus r become 0. So that becomes 0. Now r is 0, r becomes 0. So this whole term becomes 0. We have this constant is for both this. So putting the constant here we can write minus 4e square by a0 cube. Only this term we have to calculate. This term is equal to minus into a0 by 2 minus become plus an integral raised to minus 2r by a0 dr from 0 to infinity. So this become equal to, we can cancel some things from here. This become 2, this is square, minus 2e square by a0 square integral of minus, this is minus 2r by a0 by minus 2 by a0 from 0 to infinity. This is equal to this come here. So 4 a0 is e square divided by a0 square into, here in this integral when we put the upper limit infinity this becomes 0 and when we put the lower limit this becomes 1. Here it is sorry, I made a mistake here. This 2 and this 2 become cancelled. So this, there is no 4 here. This 4 become, there's no, it's not here. Okay, so what is remaining is equal to minus will get cancelled, so becomes plus. So there is a minus here and this a0 and a0 square will get cancelled. What is remaining is e square by a0. This is the expectation value of potential energy of the oneness shell, oneness state. So what we know, E is equal to, and E at one the state is equal to minus E square by 2a0. So this is number 2. We already obtained number 1, E square by 2a0. So for n is equal to 1, this is E square by 2a0 minus E square. Minus E square by a0 minus E square by 2a0. So comparing these two, what we get, expectation value of energy is equal to half times expectation value of potential energy. This theorem has a name. This is known as Virial theorem. So hope everyone understood this, and this is not very simple. You have to have the awareness about some of the like wave function, what is energy, these things. If you already know, we can easily calculate this. So I hope everyone understood this. Let's meet in the next video with another question. Till then, goodbye.